With the Pythagorean theorem, if you know two sides of your right triangle, you can find the third. This section is about two types of special right triangles. Because of their special angles, you only need to know one side to figure out what the others are by hand. The two types of special right triangles are 45-45-90 or 30-60-90. Today we're going to explore just the 45-45-90. Example 1. Find x and y in the triangle. If you know it's a 45-45-90, let's see. We know if this is 45 degrees, this is 90, this must be 45 degrees, so x must be 3. How do we find y? We use Pythagorean. We have 3 squared plus 3 squared equals y squared. 9 plus 9 is 18. So y equals the square root of 18, which can be simplified because there's a perfect square that lives in 18, and that perfect square is 9. So we can think about this as square root of 9 times the square root of 2, which is simply 3 root 2. So let's do 2 more practice problems. Again, we have a right triangle. It's an isosceles right triangle, which means that each of these angles are 45, although that's not what we're going for. In this problem, it wants the side lengths. But we can set up also, so x is 5, because we know from ITTC, the converse, that if the base angles of a triangle are congruent, the angles, well, we can see it's 5. Okay, again, we do 5 squared Pythagorean plus 5 squared equals y squared. 25 plus 25 is 50. Square root of 50. Biggest perfect square in 50 is 25. So the answer here was 5 root 2. One more example. Example 1b. We have x is 11. 11 squared plus 11 squared is y squared. 11 squared is 121 plus 121 is 242. The square root of 242? Can be thought about as square root of 121 times the square root of 2. That simplifies to 11 root 2. So, generalizing, what do you think is the hypotenuse with doing all that math out if you have an isosceles right triangle with side length of 137? Well, you would know this is 137. We could do the Pythagorean theorem, and my guess to the value of the hypotenuse, and it's actually not even a guess, it's the actual perfect answer, is 137 root 2. In general, if you have an isosceles right triangle with leg A, the hypotenuse would always be a root 2. Of course, this is always going to be a. A root 2. Okay, so if you go to the next page, there's some examples, and I'm going to choose a few to do, and then you'll fill in the rest for tonight. If this is an isosceles right triangle, this leg is 207, x has to be 207, square roots of 2. In B, I bet you can tell me what x is in this one. I'm going to leave that because it's pretty straightforward. For C, let's see, you have x is the hypotenuse. Each side is root 3, and of course it's at 45-45-90. So what would x be? Well, you'd have to do root 3 squared plus root 3 squared Oh, no, we're not doing that, are we? We are definitely not doing that. We're gonna use the relationship we just learned. So x, well, you can think of this as being a, right? So we know that x, or the hypotenuse, is a root 3. Okay, well, if a is root 3, sorry, a is root 2. You would have root 3 times root 2, so that answer would be root 6. Okay? I'm going to skip down and do letter F, because letter F is a little more complicated. 10 is really my a root 2 thing, isn't it? 10 is my hypotenuse. This is x, or we can think about that as a. So this is x root 2. Does that make sense? So if I solve this for x, I'd have to divide both sides by root 2. Dividing both sides by root 2, I'd get 10 divided by root 2 equals x. However, mathematically, we do not prefer, it's a no-no to have square roots in the denominator, so we rationalize it by multiplying the fraction by a factor of 1, or actually 1, so that the roots cancel in the denominator. Our numerator is 10 root 2. Our denominator is root 2 times root 2, which is actually 2. Simplifying, we take a 2 out of the denominator and a 2 out of the numerator. Our final answer is 5 square roots of 2. Again, I'd like you to fill in letter B, letter D, and letter E for some practice at home. 3A is similar to what we just did, and 3B is simpler. 3B is similar to what we just did, so you can do these. Actually, I'll give you the answers to 3B. It's 25 root 2, but I do want you to go ahead and go back and figure out why it's 25 root 2. Okay? Now, practice number 4 is challenging because it has 2 right isosceles triangles that are connected. So we want to find x, but we only have the number over here. Here's 7 here, right? So I guess if we could figure out the hypotenuse of this left side triangle, we could use that information to figure out what x is. So let's just get us started. Okay, so this is an isosceles right triangle with a leg of 7, which we think about as a. So this thing has to be 7 root 2, which is the hypotenuse of this triangle, right? 7 root 2. Oh, but this is also an isosceles right triangle with length of 7 root 2 as one of its legs, or both of its legs, because it's isosceles. So how we would figure out x is we'd have to say, oh, x is 7 root 2, which is the length of one of its legs, times root 2. The same idea as a root 2, right? So 7 times root 2 times root 2 is 7 times square root of 4, which is 2. 7 times 2 is 14. So again, I want you to finish B for tonight. Going back up here, make sure you show me the work for practice 3B, practice 3A, and B, D, and E. Please make sure these are all done for tomorrow in class.